Everybody, my name's Aiden, and I'm here to review the second unit of AP Physics 1, Dynamics. So the biggest part of this unit is just forces. You'll learn all about forces. So to calculate net force, it's mass times acceleration, and since it's mass times acceleration, you just take on the units of mass and acceleration. So units of mass are kilograms, units of acceleration are meters per second squared. So you just combine them, you multiply them kilogram meters per second squared, or to shorten it, it's called a Newton. Most common forces are weight force, or that's just the force due to gravity. Normal force, that's the force from a surface, but it's perpendicular to the surface. Like anything resting on a surface has a normal force from the surface. Tension, that's a force from a string, which is a very, very common force. It doesn't really have any like equation to solve for it. It's just a very common force that they use on AP questions. Spring force, that is just force from a spring. You can solve for that. I'll get into it later. Friction force, you can solve for that. It relates to the normal force as well. But friction force, there's static and kinetic friction. Static is when you're like pushing on an object and it's not moving. It's because there's static friction. And then kinetic friction is when you're pushing on an object and it is moving. And oftentimes they'll just tell you to ignore friction in equations. And then push force is just anything else. So force due to gravity, you can calculate that by multiplying 10 times whatever mass you have, or you can use 9.8 or 9.81. So if you have 3 kilograms, you multiply 10 times 3, and you get 30 newtons. That's the force due to gravity, or the weight force on that object of 3 kilograms. Normal force is just by a surface. If the surface is horizontal, then the normal force will be equal to the force due to gravity. So in the example before with the 3 kilogram object, and it's resting on a horizontal surface, the normal force will also be 30 newtons. So tension, just force exerted by a rope. Spring force is the force exerted by a spring, and it depends on the spring constant and the displacement of the spring from equilibrium. Friction is just force exerted by the ground when it's going parallel to the ground, and it's proportional to normal force. You can calculate that with a friction coefficient. And then push force is just a vague term for everything else. Like if you're pushing on an object, you're exerting a push force. So free body diagrams, this is one of the most important parts of this unit, is knowing how to draw one of these. They're very useful, and they also count for points on AP tests often. So this is a good example of one. This object, you draw a dot for whatever the system is. This one has a weight force. It has a normal force acting on it by the surface. It has a friction force that's going in the opposite direction of the acceleration by the ground, and then a tension force from this string that this person is pulling. So you have to always be aware of how many forces there are on an object, and what the net force is, and how they're related to each other. So F equals ma. This is how you calculate net force, and you can only solve for one direction like x or y or z or whatever, but they'll never give you three-dimensional motion. So when net force equals 0, you can just write F equals ma equals 0. Then you can solve for individual forces, because then you know that all the forces cancel out. And if you know components, you can solve for other components, like by isolating variables. So this is the first dynamics example problem. It's a pretty easy one. A 15 kilogram wagon is pulled to the right across the surface by a tension of 100 newtons at an angle of 30 degrees above the horizontal. A frictional force of 20 newtons to the left acts simultaneously. What is the acceleration of the wagon? So you write F equals ma, and then you do cosine of 30 degrees because you're looking for the horizontal force. So that's 0.866, and then you multiply that by 100 newtons, which is the force of tension. You subtract the 20 newtons that's going in the opposite direction, and you get 86.6 minus 20, and so the total net force is 66.6 newtons acting in the right direction. And so that equals 15 times the acceleration, because you can sub in 15 for mass, because the system is 15 kilograms. You divide both sides by 15, solve for acceleration, and you get A equals 4.44 meters per second squared. The next one is even easier. An object feels two forces, one of strength 8 newtons pulling to the left and one of 20 newtons pulling to the right. If the object's mass is 4 kilograms, what is its acceleration? So you write F equals ma, and then you have two forces, so equals 20 minus 8, and it's 12 newtons is the net force. So that equals 4 times acceleration. You divide both sides by 4 to solve for acceleration, and it equals 3 meters per second squared. So really, this unit is Quite simple. So, see you next time. Thank you.